My name is Douglas Norberg, and the title of this video is Light Speed Cannot Be Absolute. In 1881 and in 1887, Albert Michelson did an experiment called the Null Result of the Interferometer. In that experiment, he made the same assumption as what was later called the Einstein synchronization convention, that light speed is not cumulative to the motion of its propagating object. It does not take up the speed of the propagating object. In so doing, he used a machine he invented called the interferometer because it measured light wave interference. A simple diagram of the machine looks like this. I'll give you a few seconds to digest that. As you can see, if light speed, if one of the arms of the interferometer is moving parallel to the direction of motion, the distance of the one that is parallel, the arm that is parallel, is longer than the distance of the arm that is perpendicular. Therefore, the light waves arrive later and should show wave interference, a series of light and dark lines. It did not show wave interference, and as a result, the experiment was called the null result of the interferometer. What surprises me now is that no one has questioned the assumption of non-cumulative light speed. If light speed is cumulative, it picks up the motion of its propagating object. The increased speed of light will exactly offset the speed of the interferometer and arrive at exactly the same time as the perpendicular beam and show no wave interference. That is exactly what the null result of the interferometer showed. The null result of the interferometer proved that light speed and the speed of its propagating object are cumulative. The reason that in order for the LIGOs to work, light must vector. Instead of moving directly perpendicular, it will move diagonally. The accepted explanation of the null result of the interferometer is that motion causes time to dilate and space itself to contract, the theory of relativity. So you have two theories, one simple and one complex. Which one is more likely to be true? Now the listener should be asking, yes, but what proof do you have? The proof is that if light is non-cumulative, the two LIGOs, one at Livingston, Louisiana, and the other at Hanford, Washington, won't work. LIGO stands for Laser Interferometer Gravitational Observatory. Their purpose is to measure gravitational waves. The arms of the LIGOs are 4,000 meters long. If light speed is non-cumulative, one of the laser beams cannot arrive at its 14-inch mirrors. The speed of the Milky Way against the cosmic microwave background is 368,000 meters per second. The speed of light is 299,792,458 meters per second. The speed of the Milky Way is therefore 1.23 1,000th of the speed of light. Therefore, for every 1,000 meters light travels, the perpendicular on the interferometer travels 1.23 meters. 4 times 1.23 is 4.91 meters, or 16 feet. When the laser beam arrives, the perpendicular mirror will be 16 feet down range. The LIGO won't work. But you say that I don't know that one of the arms of the interferometer is directly perpendicular to the speed of the galaxy against the cosmic microwave background. That is correct. What I do know is that there are two LIGOs at different latitudes. I therefore know that one of their arms are pointing in all 3 dimensions. I also know that the greatest possible angle for any two perpendicular lines is 45 degrees. Since the sine or cosine of 45 degrees is 0.707, I know the minimum distance of travel for the interferometer at 368,000 meters per second is 11.39 feet. One of the laser beams will miss its mirror. Other speeds support this conclusion. The speed of the solar system around the Milky Way would cause one of its mirrors to move at least 1.77 meters and miss its mirror. The seasonal speed of the Earth around the Sun would cause the interferometer to move at 2.231 meters, and on the return trip another 0.231 meters. The laser beam will not arrive back to the half-silvered mirrors. The LIGOs won't work because light vectors, and if light vectors, light speed and the speed of its propagating object must be cumulative. The Einstein synchronization convention cannot be true, and the basic assumption for the theory of relativity is false. I have prepared a couple diagrams that will show you what should happen. As you can see by this one, when if the light is non-cumulative, the mirror moves downrange, and the light will miss its mirror. On the other hand, if the light wave is cumulative, the light wave vectors move diagonally, hits the mirror because the same phenomenon causes the mirror to move as causes the light to vector. It vectors again and hits the half-silver mirror here and returns to the observer. As I said, the Einstein synchronization cannot be true, and the basic assumption of the theory of relativity must be false. Thank you very much.
That was really good. You actually, the whole thing was better than the first one too. Your instructions, everything. Okay. So